Hey everyone and welcome! Today we're going to pull back the curtain on the core logic that powers so much of our digital world, from the apps on your phone to the most complex video games. We're going to break down how modern programming handles massive, and I mean massive, amounts of data, all using one simple but really powerful analogy. So, let's dive in.
So have you ever really thought about it? In a game, every single character has its own health, its own inventory, its own location. On social media, every user has a unique profile, a different feed. How on earth does a program keep all of that straight without just, collapsing into total chaos? The answer is a brilliant concept called object-oriented programming, or OOP for short.
And the absolute heart of all this, the core idea, is the class. Now, the best way to think of a class is as a master blueprint. It's not a physical thing itself, right? It's the detailed plan. It's the set of rules that defines all the properties and capabilities that something of a certain type should have.
And here we can see what that blueprint actually looks like in Java code. This student class is basically a rule book. It says, hey, any student we decide to create must have two things: a name, which is going to be some text, and an ID, which will be a number. That's the plan, laid out clear as day.
Okay, so if the class is the blueprint, what do you get when you actually follow the plan and start building? You get an object. An object is the real thing, the actual house constructed from the plans. It's a living, breathing instance of that class that exists in the computer's memory, and it has its own specific data.
Creating one of these buildings from our blueprint is a pretty clear three-step process. First, you have to declare a space for it, kind of like reserving a plot of land. Second, you instantiate it, this is the big moment of creation, using a special keyword. And third, you initialize it, which is like calling in the construction crew to handle the initial setup.
In this one line of code, it shows that entire process perfectly. We declare a variable student S1. Then we use that magic new keyword to actually build a brand new student object in memory. And that student part at the end, that's the call to the construction crew to get it all set up. Just like that, our blueprint has become a real, tangible object named S1.
So, what's actually inside every single object? Well, it boils down to two fundamental things. On one side, you have its state. That's its unique data. Our S1 object might have an ID of 100 in the name Java, but another student object could have a totally different ID and name. And on the other side, you have its behavior. This is all about what the object can actually do. Those behaviors we just talked about are defined by methods. Really, a method is just a block of code that performs a very specific task. For our student object, we might have a method to, say, insert their data into a database, or another one to display their information on the screen. These are the actions our building is designed to perform. Now, let's circle back to that initialization step, that initial setup. This is handled by a very, very special type of method called a constructor. And the construction crew analogy? It's perfect. The moment you use that new keyword, the constructor for that class is automatically called to do all the initial setup work, making sure the object is ready to go.
And you can have different kinds of construction crews. A default constructor is like the basic crew. It builds a standard model and just gives it some default values, like 0 for a number or just null. But a parameterized constructor, that's like a custom crew. It lets you give specific instructions right from the start, so you can build tons of unique objects, each a little different.
Okay, let's throw a little twist into this. What if there's a piece of information that should belong to the blueprint itself and not to each individual building? For instance, what if all our student objects go to the same college? It would be really inefficient to store the college name inside every single student object, right?
The solution to this puzzle is the static keyword. Just think of it as a special rule that's written directly on the master blueprint. When you declare something as static, you're saying, hey, this belongs to the class itself, not to any one of the buildings we create from it.
And this is incredibly powerful for a few reasons. It's perfect for a common property like a college name because it saves a ton of memory. That name only exists in one single place, at the class level. And get this, if the college ever changes its name, you only have to update it in one place, on the blueprint. And every single student object automatically reflects that change. Pretty cool, huh?
Now, with all these objects being created left and right, what happens when we're done with them? Well, this is where Java's garbage collector comes in. It's basically an automatic cleanup crew that runs in the background. It goes around and finds any objects that aren't being used anymore and destroys them, freeing up that memory. It's a huge feature that makes managing memory in Java so much easier.
All right, let's look at one final super important keyword, this. It can seem a little abstract at first, but our analogy makes it simple. It's how an object refers to itself from the inside. It's like a building being able to say, my own front door, or my own ID number. And you see this used all the time just to make things crystal clear. Imagine a constructor gets an input parameter named ID, but the object also has its own internal variable named ID. It's confusing. Which ID are we talking about? By writing this.id, we're being totally unambiguous. We're saying set this object's own ID to the value of the ID that was just passed in. Problem solved.
So, to bring it all home, let's just summarize. It's really this simple. A class is the master blueprint. It defines the structure and the behaviors. An object is the actual, real thing you build from that blueprint, with its own unique data. That separation is what makes this whole thing so incredibly powerful.
And this isn't just some academic concept, not at all. This model is revolutionary because it allows for amazing organization and reusability. Once you've perfected a blueprint, you can use it to build millions of reliable objects. It is the absolute foundation of so much of the software that organizes our modern world.
So I'll leave you with this question to chew on. Now that you can see this powerful pattern, defining a template and then creating real things from it, what else in your world could you model this way? A car? A recipe for a cake? A bank account? The possibilities are literally everywhere you look. Thanks for watching.